Hello everyone. This is lesson 8, solving linear equations, and I will guide you through the pencil problems. But a little commentary first. Make sure you understand that an expression, an algebraic expression, does not contain equal signs. So maybe 3x plus 5 minus 2x minus 9 would be an example of an algebraic expression. Notice there is no equal sign. But in an equation, we will have an equal sign, as you can see in the pencil problem. Now, a very simple equation would be something like, for example, x plus 5 equals 9. And just not even knowing any algebra, we would have to say that x equals 4 would be a solution, because, and I'll just abbreviate because as cuz, if we put the 4 back into the equation, obviously 4 plus 5 equals 9, because 9 equals 9, and that would check. So the idea here initially is to determine if a proposed value of the variable is a solution to a given equation. And in our example, you could see we're asked to determine if this value of x, -3, is a solution to this equation. So obviously this equation is much more complicated than this simple equation, and you can't just guess at a value of x that would satisfy it. Maybe it's even a fraction. So we're going to, in this lesson, develop the algebraic techniques to be able to solve equations such as this. But initially, we just want to test and see if a proposed solution is in fact satisfying the equation. So to do so, we just substitute or replace. So we just replace x by the proposed value, and you can see we did that in here. You could read through the rest of the example. The statement was false. And if the statement is false, then the proposed solution is not a solution. So let's see what happens in our pencil problem. So I'm going to rewrite the equation. 3x minus 7 equals -25. And the proposed solution is -6. So we make a substitution or a replacement, and recall that when we make a substitution or a replacement, we want to put parentheses around the value that we're substituting. So 3 and in parentheses a -6, of course that means multiplication, and that's why we like to use the parentheses, and then we just recopy everything else. Now I'm going to put a little question mark above the equals, because I don't know if that's true or not. But now we just do the arithmetic. So 3 times -6, -18, recopy, -7. Is that equal to, I don't know yet, a -25? And now if we combine a -18 and a -7, we get -25, and -25 equals -25. So therefore, that's a true statement, and then we could say that x equals -6 is a solution. Okay, so now we need to develop the techniques in order to be able to solve these types of equations. And the first property is the addition property of equality. Now remember, addition and subtraction are the same, are inverses of each other, and basically what this property is saying is that we could add or subtract any number we want to both sides of an equation and obtain an equivalent equation. So in the example, you could see that in order to isolate the variable, because that's our goal. If it's x, y, n, whatever it is, whatever the variable is, we want to isolate it. And in order to isolate the y in this equation, we had to undo the negative 9. And to undo it, we add the opposite. So we added 9 to both sides of the equation and did the arithmetic, and we even showed a check. So the checking is optional, but to the pencil problem. Now again, I'm going to recopy. Minus 9 equals x plus 7. And one thing is, I know that most students are comfortable when the variable is on the left side of the equation, but if it's on the right side, just leave it there and become versatile with your algebraic solutions. So there's no need to worry about the fact that the x is on the right. Just the idea is to isolate it. So basically we need to get rid of this positive 7. So we add the opposite. Now notice the structure of the solution. I'm going to subtract 7 here. I'm going to line up equal signs. And I'm going to subtract 7 from this side, because whatever we do to one side, we have to do to the other side to keep the equation balanced. And I'm going to draw a long addition bar. And then on the left, do the arithmetic. Minus 9 minus 7 combined gives minus 16. Bring down the equals. Just bring down the x, and these 7's go away. There's no need to write a plus 0 or anything. And negative 16 equals x is the solution. And that's the same thing as saying that x equals negative 16. Okay, so then we have another property, the multiplication property. And we already know this one from solving proportions. We know we could divide both sides of an equation by any number we want, except 0, of course. And the same thing goes here. We can multiply or divide both sides of an equation by anything we want, except 0, and obtain an equivalent equation. So you can see in our example, we showed this in one of two ways. First, by multiplying by the reciprocal, but then alternatively by division, dividing by the coefficient. So remember the terms. When we write 4x, we understand the 4 is being multiplied by x, but the 4 is referred to as the coefficient, and the x is the variable. So we divide both sides by the variable. And if the coefficient of the algebraic term containing the variable is an integer, then it's easiest to proceed with this alternative technique by just dividing both sides. So you could read through the reciprocal case, and obviously we've already seen the division case. So getting down to the pencil problem, I'm going to recopy again. Minus 7m equals negative 63. And now I'm just going to divide by the coefficient of the variable. And we divide, and I'm going to take an extra step to show this, and we divide by the coefficient sign included. And whatever we do to one side, we do to the other, so the negative 63 gets divided by negative 7 as well. Now formally what happens is these negative 7's cancel. We could replace them by 1's. We get 1m over 1, or 1m, or just simply m. And you don't have to show the cancellation, but formally that's what's happening. And then we do the arithmetic. 63 divided by 7 is 9, and negative divided by a negative is a positive. Now, so that's our solution. Now I know what some of you are going to do. When you see this type of situation, and this is fair game, you could do this if you like, but just watch carefully. Instead of writing the extra step, which is something I am always going to do for reasons that will become obvious as we progress to more sophisticated equations, many of you will get in the habit of seeing a situation like this and just jumping right in without rewriting, and just jumping right in and doing the division. You'll show divided by -7, divided by -7, and then proceed to the solution. So feel free to do it that way, because most people do. But again, I'm going to show this step for reasons that'll become obvious in the future. Now, when we have rational or fractional coefficients, there's a couple different ways you could proceed. Actually 3, and we only showed you 2 in our example. We showed the concept of the reciprocal again. So notice the coefficient of x is a fraction, and we use the concept of the reciprocal of 3/5, which is 5/3, to multiply both sides by the reciprocal. Alternatively, we talked about dividing here, but it's cumbersome to divide fractions. So that might not be the most efficient way to proceed. One way that we haven't shown that I'm going to show here is what I call the proportion method. If you have an equation such as 3/5 x equals 12, where the coefficient is a fraction, what you could do, instead of writing it as 3/5 x, you could write it as a single fraction by letting the variable x be absorbed into the numerator. So instead of 3/5 times x, you could write it as 3 times x over 5, or 3x over 5. And then if the right-hand side is just a single number, an integer, that is, make it a fraction by putting it over 1, and then you could just think of cross-multiplying. So 1 times 3x is 3x, 5 times 12 is 60, and now we'll just simply divide by the coefficient, 3, and we get the same answer. So I feel the proportion method is easier for students, but it's your choice. If you like the reciprocal method, that's fine. And let me just quickly show you both methods here. Using the concept of the reciprocal, we'll multiply by 9 over -2, or -9 over 2. Both sides of the equation. I would probably want to put the 14 over 1 as well. And then what happens on the left is everything cancels. Replaced by 1s, the double negative makes a positive, of course. And then on the right, the 2 can go into the 14 7 times. 9 times 7, 63, so negative over 1 times 1, or just -63. So that's the reciprocal method. Alternatively, the proportion method. So starting with the given equation, I'm going to rewrite it as -2y over 9 equaling 14 over 1, and cross multiply. So 1 times -2y, -2y, 9 times 14, if you need your calculator, -126, positive 126, and now divide by the coefficient, sign included. Never put the variable, when you do this division, never put the variable in the denominator, only the coefficient, sign included. Because you're trying to solve for that y. See, these guys cancel again, replaced by 1s. Gives you 1y over 1, 1y, or just y. Do the arithmetic. We get -63. So your choice as to how you want to proceed. Okay, now we want to combine these rules. So use the addition and multiplication rules together. The last rule we're going to use is the multiplication rule. That is, the last thing we want to see is something of this form, ax equaling b. where there's the variable isolated on one side and the number on the other side. And then we're going to use division, or if we have a fractional coefficient, the fancy thing we just talked about. But typically, it's just going to be division at the end. And so, worst case, ax equal b, something containing the variable on one side and the numbers on the other side. So you can see in this example, we have the variable on the right, so we want to isolate it. So the first thing we're going to do is try to obtain this form by subtracting 9 from both sides. And you can see we did that here, and then finally the division. So we're just putting the two steps together. So it's just a two-step problem. So here's my example, minus 3z minus 8 equals negative 16. Now, I think I've made my z's for you before, but just so you know, here's a 2, and my z's look like 2's, but with a little line through them. So we want to isolate the z. Note that the variable is just on the one side of the equation. We want to isolate it first by undoing the negative 8, add the opposite, so just add 8. Draw the long addition bar. Now, these 8's are gone. There's 0. There's no need to write a plus 0 there. And this negative 3z, you don't have to just bring it down in the position that it is in. You could bring it down and tuck it right next to the equal sign. And then do the arithmetic here, and we get negative 8. Oh, I'm sorry, I made a mistake. I copied the problem down wrong. This was a positive 16. And so therefore, doing the arithmetic, now we have 16 plus 8, which is 24. Okay, and now finally a division. So it's a two-step problem. And so we're going to divide by the coefficient of z, divide by negative 3. So 24 divided by negative 3. These negative 3's cancel. Get z equals negative 8. Okay, now there is a situation where the variable may be on both sides of the equation. If that's the case, then you want to choose a side to bring the variable to. And in our example, we showed both situations. So first off, note that the variable is on both sides, and we want to bring it to one side. So it's your choice. And our suggestion, always bring the variable to one side first, and then deal with the constants. And so this method showed isolating the variable on the left, where we first subtracted 3y, and then notice we had a problem just like the last example from there. And this method here showed bringing the variable to the right. Now, I know most students are comfortable bringing the variable to the left, but the reason why we sometimes bring the variable to the right-hand side is to ensure that the coefficient will be positive. So to bring the variable to the side that the coefficient is greater is the general rule. But it's your choice. You don't have to. You could do it any way you like. Okay, so I recopied the problem, this time correctly. And I first note that the variable is on both sides of the equal sign. So I want to bring the variable to one side. I'm going to choose to go to the left because 8 is greater than 5. So I'm going to subtract 5x. Now when you do this, again, follow the structure, line up the equals, and line up the x's together, because those are like terms, and then the big addition bar. And then 8x minus 5x gives us 3x, and we just bring down the negative 3, line up the equals, the 5x's go away, no need to write a 0 there, just bring the negative 24 down, and tuck it right next to the equal sign. And now notice that we have our two-step problem. That is, variable and constant equals a number, isolating the variable. We want to get rid of this -3, so we add the opposite, or add 3. And if we add 3 to both sides, there's the addition bar once again. These 3's go away. We'll bring down the 3x, and again, tuck it right next to the equal sign. -24 plus 3 is -21. And now finally division. So I'm going to rewrite it and show the division, and we get that x equals -7. So moving on, we have a situation now where we're going to add another step. Before we start transposing, so that's a fancy term that we use to indicate that we're moving terms from one side of the equation to the other. Before we start the transposition, the worst case we should see is ax plus b equaling cx plus d. That is something like the last example where you had variable and a constant equal to a variable and a constant. If you see more than 2 things on either side of the equal sign, that means you can combine like terms on that particular side. So you can see the situation here. You could read through the example, and I'm just going to jump to the pencil problem. And I'll recopy the equation. 5x minus 12 plus 11 equals a -7x minus 9 plus 2 plus 14x. Okay, so there's an equation with a lot more than we've seen at this point. But remember, worst case, before transposing, ax plus b equals cx plus d. Okay, so on the left, I see more than 2 things. That means I could combine something. There's no other x's on the left, so I recopy the 5x, but I can combine the -12 and the +11 to get -1. Now the equal sign is our barrier, so we only combine on the left and the right separately. Now on the right, we see 2 terms that contain x, a -7x and a +14x. And combining, we get a +7x. And then we also see these constants are alike. And so combining a -9 and a +2, we get a -7. Now, we want to bring the variable to whatever side you like. For fun, I'm going to bring it to the right. And the reason why is because the coefficient of x is greater on the right. It's 7 as opposed to 5. For fun, you could go home and you could bring the variable to the left and just make sure you get the same answer. But if I want to bring the variable to the right side, I'm going to subtract 5x. And again, notice the structure, how you line up the equal sign, the addition bar. Then 5x's go away, I bring down the -1, equals 7x minus 5x is 2x, bring down the -7. Okay, at that point I've got the variable on the right. I want to bring the numbers to the left. So I'm going to undo this -7 by adding 7. There's my addition bar. And we have 6 equals 2x. And now finally the division. So we're going to divide by 2. And 3 equals x. Or, as we know, that's the same as saying x equals 3. Okay, so one more thing to add, and that is the distributive property. Recall the distributive property. If we have something of the form a multiplied by b plus c, you can use these little arrows to indicate the distributive property of multiplication over this addition. So A gets multiplied by B, so we say AB, and then plus A gets multiplied by C, so AC. And so that's the first thing we do, is remove the parentheses if we see them in an equation. And you can follow through the example. We'll jump to the pencil problem. Again, I'll recopy. 7x plus 14 equals 4 times the quantity, in parentheses, x minus 7, and then plus 9. So on the left-hand side, there's nothing to do. We'll just recopy 7x plus 14. But on the right, the 4 gets distributed. So 4 times x, that's a 1x. You could slide a little 1 in there if you like. And that gives us 4x. And then 4 times negative 7 is negative 28. Now the closure of the parentheses stops the distribution of the 4, so we just recopy plus 9. Now, on the left we see two things, two terms. They're not like, so we can't combine, but on the right we see 3 terms, so we know we can combine something. And in this case, it's the constant terms. So we recopy the 7x plus 14 equals 4x, and then minus 28 plus 9 is minus 19. Now bring the variable to whatever side you like. I'm going to choose to bring it to the left because the coefficient of x is greater. So I'm going to subtract 4x. Again, notice the structure. Hopefully you're following this when you do your work as well. Line up the like terms and such. 7x minus 4x is 3x. Bring down the plus 14 equals... These guys go away. There's no need to write a 0. Just bring down the negative 19 and tuck it right in there. And then we need to isolate the x. We have it on the left side, so therefore all the constants on the right. So we're going to subtract 14 from both sides. And that gives 3x equals negative 33. And then finally the division. So 3x over 3, negative 33 over 3, and we get x is negative 11. Okay, so our final example in the pencil problem is just an extension of these concepts. So you can read through the example. Notice there's a couple sets of parentheses. And to the pencil problem, I'm going to recopy 9 in parentheses 2y minus 3 equals 5 in parentheses y minus 4, close the parentheses, plus 7. So the distributive property twice. First with the 9, multiplied by 2y gives 18y, distributed 9 times negative 3, negative 27, equals, distribute the 5, times y, 5y, you can put the little 1 in there again if you like, and 5 times negative 4, negative 20, and plus 7. Okay, on the left there's only 2 terms, they're not like, so just recopy, but on the right we see 3 terms, so we know something can be combined. There's only one thing containing y, the 5y, which we recopy, and combining the negative 20 and the positive 7, we get negative 13. Okay, now the variable is on both sides again. Bring it to one side, let's say the left, by subtracting 5y. And we have 13y minus 27 equals a negative 13. If we brought the variable to the left, we bring the constants or the numbers to the right. We have to undo negative 27. So add 27 to both sides. And we bring down the 13y, tuck it next to the equals, combining negative 13 and 27, we get 14. And finally the division. Okay, so here we get a fraction, 14 over 13, and that's our answer. We can't do any better than that. Don't be surprised to get fractions as your solutions. And we prefer improper fractions over mixed numbers, so we're going to leave it as 14 over 13. Okay, so that's the end of lesson 8.